All right, so our next topic is turning points. And this is a cubic function. And this function, if we think about time starting way back, like maybe the x-axis is time or distance. But at any rate, we always go left to right. So if we're starting way off here somewhere, this function started at minus infinity. It increases as x moves along the axis in this direction until it gets to this point. And then the function, or the y value, or the f of x value, is actually getting smaller and smaller. So it's decreasing until it hits that point that I just circled. And after that, it's increasing again. So you can see why those are called turning points. And we define a turning point that's higher than nearby. Sorry about that. Like this point here. We define this as a local max or maximum. And the second point over here, because it's lower than all the other nearby points, we call that a local minimum. And the fancy math word for max and min values, they're called extrema. All right, so looking in particular at this Desmos function plotted over here on the right, it's a plot of the function x to the third minus 6x to the second plus 7x plus 2. So it has a relative maximum at 0.709, comma 4.303, and a relative minimum at 3.291, comma minus 4.303. All right. So then what we say are the intervals where it's increasing. Well, we lay these out by starting back at minus infinity. So if we look at this function starting at minus infinity, it increases all the way up until you put in an input value of 0.709. And then from 0.709 all the way until the next value of 3.29, it's decreasing. And then from an x value of 3.29 all the way to plus infinity, it's increasing again. So notice that we talk about increasing and decreasing intervals in terms of x. The x value is like the anchoring coordinate of where your input is. And we talk about maxima in terms of both where they're located in x, but also what their output is, the actual value at that x.